Let us start now. Yesterday, I have discussed the interpretation of gamma x, gamma y, and gamma z, gamma xy, gamma yz, and gamma zx as shear stress components. But let us discuss it again because it's a very critical matter. This is shown earlier that we know epsa xx means and it is an elongation or strain, not elongation but strain along x-axis. Normal to explain is ux delta ux by a dx delta uyy epsilon y double y and strain along y-axis normal to the y plane means is a tensional or a time extensional strain delta y by y and epsilon z strain along z axis along z axis normal to the z plane, which is nothing but the tensile strain along tensile or compressive strain along z axis delta uz by delta z, which means we are we have discussed that what is ux uy and uz, which is the direction cosine of a particular line vector or displacement vector along x-axis, y-axis, and z-axis. And we are thinking that in terms of x, that rate of change of this ux means cos vector, cosine vector at x-axis, y-axis, and z-axis in terms of x, y, and z respectively. So this is the rate of change of cosine vectors if according to same cosine vector along x-axis, and rate of change is along x-axis itself, and uh, क्या हो गया भाई now now we have interpreted the linear strain in line elements parallel to the x, y, and z axis, because first of all we have discussed the linear strain component of linear strain along x, y, and z axis by saying that our restricted line vector PQ is not along any of them, and their components along x-axis, y-axis, and z-axis. We have discussed how we have to calculate. Next, we decided to calculate the linear strain along either x-axis or y-axis, or z parallel to either x-axis, y-axis, or z-axis respectively. Now, it was also stated that gamma xy, the shear stress along normal to the x-axis and normal to x-axis and along xy plane is equal to uh, delta uz by delta y and delta uz by delta x, and gamma xy gamma yz delta uz by delta z plus delta uz plus delta y, and gamma xz is delta ux by delta x plus delta uz plus delta uz. Now, respectively the shear strengths in the xy, yz, and xz planes respectively. This can be shown as follows. in a following diagrams actually. Let us discuss first, just have a look what is going on, how we have got it here. Here it is roughly shown how it is going on, because in the here gamma xy, gamma yz, and gamma zx, just we have told at this moment, it gives this representation because all the components having higher square or cube at, or multiplication with each other are too small, and so they are all neglected and not taken into account here. So all these problem, f psi x, f psi double x, f psi double y, f psi double z, etc., all are reduced to this comparatively single form itself. Now let us go for now. Let us discuss this situation once again. What we have here is the coordinates of P. What is have here is the coordinates of P here in rectangular coordinate axis along x and along y, and we are not taking into consideration the z axis at this moment. Now, what is the coordinate of P here is x and y, means distance of vertical distance from, if you drop a vertical here and which intersect at x axis, and O to that particular point of intersection is given as x, and if we drop a vertical from P to y axis, then O distance from O to that point of intersection is given as y. Now, let us say length of the straight line P to Q, which is parallel to the x-axis itself, is given as delta x, and length of the straight line P to R, which is parallel to the y-axis, is given as delta y itself. And after the deformation of the said elements, whose points are P, Q, and R, then after deformation, P shifts to P dash, Q shifts to Q dash, and R shifts to R dash itself. And let ux, uy be the displacement of the point P. What P is displaced by an amount ux here, and P is displaced by an amount uy here. Along x-axis, it is displaced by an amount x-axis, and along y-axis, it is displaced by an amount uy. Now, what happens? Now, let us uy be the displacement of the point P, just you have told us, so that the coordinates of P dash now will become, it was originally delta x, x plus, it was x. Now coordinates of P dash here will now added by the term ux and uy, so it will be delta plus ux and delta x plus ux and y plus uy. The coordinates of P dash is equal to x plus ux and y plus uy. Next we come to the point Q. It's initially it was away from the P by an distance delta x. So the initial component, the displacement component of Q will be x initial coordinates or displacement components of P. Q is given as P plus delta x, and is given as x plus delta x and y, as it is remains y because Q is not changed in position at this moment here. So it distance initial coordinate along y-axis is equal to y, so it remains y, and the coordinate along x-axis is increased by P, which is x, and the delta x is the length of delta x. Delta is the length of PQ, so the coordinate of Q will be P plus delta x and y itself. Now, similarly, displacement of R will be x, y plus delta y, and sorry, first the displacement component of displacement vector or displacement component will be x plus delta x into y. R will be replaced by ux plus delta ux by ex into delta x, and uy delta uy plus delta x by into delta x. Argument is same as before. First we add the ux, which was the initial coordinates of x. Then we are judging the rate of change of ux in terms of x, means with change in x how the ux changes, then multiplied by the length delta x, because ux is changed by an amount delta x itself, and add it to the original coordinates, which is equal to ux. And uy is uy plus delta uy or delta x, means what is the rate of change of delta u with the change in delta x, and or well the original change is delta x, and it is added to the original coordinates, that is delta u. So similarly, the displacement components of R is x and y plus delta y are similarly ux delta ux by delta y, delta into delta y, delta ux by delta y, delta uy by delta y to delta x. So here we are judging the rate of change with the change in dx and delta x and delta x, and here we are judging the change of uh, ux along with the change of delta u, and judging the change of delta u with the change of delta y. Here we are taking into consideration of change in delta x, and here we are taking into consideration of the change in delta y, or the change of ux, ux and uy, and here is also ux and uy. Next, another thing comes that if theta 1 and theta 2 are small, which is that what is theta 1 and theta 2? This is given here. Theta 1 is the angle of displacement of q to the q dash, and theta 2 is the angle of displacement of r to r dash. Now, what happens? So theta 1 this will be tan theta, which is more is very small. So the radian theta 1 in radian will be equal to tan theta 1, which is given as rate delta uy by delta x, means it is the rate of change of uy in terms of dx itself. And because delta y, we are this was originally this point was in the original the displacement vector was on originally what we said is yes, okay, our position was this point was delta y, and due to the change in x axis, what is the rate of delta y, and that is the multiplied by the delta x itself. This also the angle here. Here also the angle is theta 2 delta ux, which is this is the component coordinates of p dash, which has changed up to p dash, rate of change of delta ux by delta y into delta y itself, means delta y is the length from here to here. The coordinates of from p to r is the length of delta r. So delta u itself, delta y, delta x. So thus theta 1 become rate of change of delta u, rate of change of uy by x, and rate of change of vx by dy. Now, so the total change in original length theta 1 plus theta 2 is equal to del ux by del y plus del ux by del y plus into gamma 1. Here what we see, okay, ठीक है, and theta delta vx by delta y. So how would this thing happen? Del theta 1 tan theta 1 is equal to delta uy by ux, and delta theta 2 to tan theta 2 delta ux and delta y is like this. Here initial the position of p was changed from y to x, y to y by dy itself. So this will be the rate of this height. We know the tangent is I mean the vertical divided by base. The vertical should be the rate of change of uy, that is delta uy, and base should be the rate of change of x, that is delta x. That's why this tangent is given as delta ux by delta y. Similarly, it following the same argument, same logic, this vertical is equal to delta ux, is rate of change of ux with change in change in position along x-axis divided by the rate of change of y, which is the change of the distance from along y-axis itself. So here also base is delta y and vertical is delta ux. That's why theta 1 and theta 2 characteristic type of equation itself. If we add theta 1 is equal to theta 2, then it will be equal to delta ux by delta y, delta uv plus delta x, or that is equal to gamma x itself. From our RDL notation, we have got the value of gamma x is equal to this value. Now, this is the shear strain in xy plane at P. Similarly, you can calculate the shear strength in yz plane and zx plane in the same way. Now, we have defined or decided the body is bent from initial position PQ and PR to P dash Q dash and P dash R dash. But it may so happen that due to the change in position, due to the external application of load, the body is not deformed like this, but it is just rotated in a certain orientation, which means I'm telling again, body is deformed. Here, what happens? PQ change to DQ, PR change to PR dash. It is deformed from this leg to here, this leg, and from here to here. But it may so happen, it remains so that, I'm sorry, so that this angle in between is less than 90 degree. But it may so happen, due to the application of external load, this whole body is just rotated in a certain direction, in a certain amount of angular rotation, without changing the in between angle between P, P dash and Q dash and R dash. How it is happens? It's like this. Here, what we are seeing that here is that again the coordinate axis OX and OY along X direction and Y direction, and here initially the position was P and Q along this direction and along this dotted line. Now the position is now changed to P dash, Q dash, and P dash R dash, but the initial angle in between PQ and PR was 90 degree. Their final angle also becomes 90 degree, but whole unit is shifted by an angular direction, angular amount, angle, or yes, angular rotation by omega z0 and omega z0. This is here, same amount is being rotated here and same amount is being rotated here itself. So it is very clear what will happen to omega z0 in the same rotation, because if initial was dy here, initial coordinate of P, which is changed to now P dash is equal to dy itself. So this is equal to rate of change of dy along x-axis, and this omega 0 here is rate of ux along y-axis. So same term omega 0 is depending on delta ux by delta y on in one case, and delta y ux and uy by delta x one direction in one direction, but they are supposed to be the same. But they both of their rate of change of ux along y-axis is supposed to be equal to the rate of change of ux along x-axis due to the rotation like this. There is a counter correction rotation as positive. Here, this rotation is counterclockwise, and both of them are counterclockwise in nature. But the negative sign we are using here, because since a positive dy will keep a movement from y to x, as shown in the figure. Initially, figure is moved from y to x itself. Here it is doing exactly the opposite, from x to y. So we are thinking that this is equal to minus du plus dy. Now there is no strain occurs during this rigid body displacement. So we can define omega z is the average of this displacement omega 0 here and omega 0 here. So half of dy by dz is minus dux by dy. But this term is defined as minus because it is supposed to be here to be positive, but it is supposed to be here if we think it is rotated from here to here clockwise direction and here to here anti-clockwise direction. So it is duy by dx minus dux by dy equal to omega yx. So this represents the average of the sum of rotation of x and y element, which is given here, the average. That's why it is added together. This has negative terms and divided by 2. And the rotational components along x and y axis willing or rotation about x and y axis. This is the rotation component about z axis. That's why it's omega z and given as omega x and y. The explain it means it is rotated around z-axis but in xy plane. Here we can say following the same rotation we can have omega x and omega x means rotation around x-axis and in zy plane, and omega y rotation around y-axis and in the plane xj. Thus, in the same condition, we are getting the similar values in terms of UZ, UY, UX, UV. So we are getting rotation among x-axis, y-axis, and z-axis. Let us go through quickly the problem we have discussed yesterday. It was the distance vector is given y square into I, 3zi yz into z plus 4x into x square into k, or whole multiplied by 10 to the power minus 2 1 by 100. So what is the rectangular strain components of the point P and point P, which is the initial inverse coordinate was 1, 0, 2. Now, anywhere if we know the initial point and we know the vector displacement field of a said mass or unit, then we can calculate the uh, the displacement of any other point around in the same mass of fluid, mass of matter, which has from we are using the displacement vector, displacement grid as well as the initial coordinates. Now, as we know Ex, which is the displacement vector itself, its component along x-axis, y-axis, and z-axis are given as ux is equal to y square, y is equal to 3yz, and uz is equal to 4 plus 6 square. Now, which is written as y square, 3yz, all are multiplied by 10 to the power minus 2, and uz into 1 plus 10 to the power plus 6 square by 10 to the power minus 2. So, if we differentiate delta ux by delta y, it will be equal to 0 because there is no x terms here. Delta ui by y, delta x is again equal to 0. There is no x term here, but delta uz will be equal to 12 into x into 10 to the power minus 2. Similarly, delta ux and uy delta ux and uy is equal to t2y 10 to the power minus 2 because here it is y square. So if the division is equal to 2y and it is multiplied into 10 to the power minus 2, delta uy, where delta y 3z, here it is 3z, this is the differentiate by, if I differentiate with the to y this quantity, this will become 3 into z multiplied 10 to the power minus 3. And if we differentiate in terms of y, here there is no y term in this equation, so this is all constant for y itself. So delta uz by z is equal to 0 itself. Similarly, we can get, if we put the value of linear strain, if we put the linear strain, the coordinates of the point P or initial point was 1, 0, 2. So we can safely find out by putting the value of 1, 0, and 2 in respective vectors, and what is the element, what is the deformation along x-axis, y-axis, and z-axis, which is supposed to be tensile in nature. So if you put the value here, we'll get the elongation of strain along x-axis is equal to 0, elongation of along y-axis is equal to 2 into 6 into 10 to the power minus 2, elongation along z-axis is also 0. So this particular element is having, we are having the elongation along y-axis only. There is no elongation on x and z-axis itself, means that displacement vector is acting along the y-axis itself. The shear strain at one, shear strain can be obtained by this equation gamma xy delta ux by delta y delta uy by delta x. Here we have calculated this value. If we put the value of x and y in 0 0, we will have 0 plus 0 is equal to 2. Similarly, gamma yz is equal to uh, delta uy by delta z delta ux by delta y is equal to 0 plus 0 is equal to 0, and um, gamma xz is delta uj uz by ux by delta z and delta uy by delta x itself is equal to 0 plus 12 into 10 to the power minus 2 and minus 2. So we have got all these extensions and all this gamma strain itself. Let us go to the new topics. The rate of change in direction of a linear element itself. Just 1 second. Now let us discuss the change in direction of a linear element itself. Now it is very easy to calculate now the change in the orientation of a linear element just resulting from the deformation of the solid body. What we have discussed so far, when the initial orientation of two mutually perpendicular axes are changing due to their external load in one case, and we have discussed again the same phenomenon when the reciprocal orientation among the reciprocal rectangular axis is not changing, that is remains 90 degree, but whole axis is being shifted by a certain amount, certain angle. So in first case, the angle between these two axes is reduced from 90 degree, and next case, the angle between these two mutually perpendicular axes is not changing from 90 degree, but its whole structure 0 x and y is just moved by an action and by an amount equal to omega z. So both the cases now it is clear, it is now explained. Now from the let PQ now the element of the length delta x, which with direction cosine nx, ny, and nz. This PQ is not along x or y or z axis, but it is making an angle to both x and y, both to all x and y and z axis itself, and cosine of that particular angle along with x and with y and with z axis given by the direction cosine. Uh, that is given as nx, ny, and nz itself. Now, after the deformation, the element p dash q dash, which is initially of length, p dash q initial of element of length equal to delta x per delta s, and after the deformation, the element becomes p dash q dash of length delta s dash, which I have discussed this issue earlier. The direction cosine now changed. As the length has changed, the direction cosine means the angle subtended by the new uh, changed angle of PQ, like the line PQ with the x, y, and z axis now changed to nx dash, ny dash, and nz dash itself. If ux, ui, and uz are the displacement component of the point P, then the ux, ui, and uz displacement component of the point P means it is the coordinate of the point P, or it is the angle sub. It is the cosine of the it is the initial coordinate of the displacement, initial displacement of the point P. Then the displaced components of the point QR will be ux plus delta ux, y dy plus delta uy, and uz plus delta uz. Means all these component from P to P dash is increased by an amount delta vx along x-axis, the same delta y by delta y-axis, and delta uz along delta along z-axis. When delta ux, uy, and uz are given in what we have calculated in earlier in equation 4, 5, and 6, we have given the value of ux and ui and uz. Now, from our earlier equation, we know that in linear range, if pq is epsilon q and delta s dash is delta s multiplied by 1 plus delta p delta 1 plus epsilon pq, where epsilon is the strain of the line pq or rate of change of the line pq. So final length delta s dash is equal to initial length plus the rate of change of the rate of change of the initial length itself. The components of p and q, p dash and q dash, will be given as follows. As we have already discussed this situation, p is equal to given as coordinates x, y, z. Q is increased by an amount delta x along x direction, y along delta y along x direction, and z along plus delta z along z direction. So p dash ux, u plus delta ux, y plus uy, z into z plus uz. So we have got all these things. This the change coordinates of change to p dash and p dash, p to p dash. So change by an amount ux, uy, and uz, and coordinate of q from x it is away by an amount delta x, delta y, and delta z, and coordinate q dash will be the x plus delta x plus ux plus delta uy. Same delta y x plus y plus delta y is equal to delta uy plus delta u, and z plus delta z plus delta z plus delta delta uz itself. So nx, we know the direction cosine along the length along x divided by the total length by the length of the line PQ, and delta x is the its projection of the line along x-axis. So the cos x equal to cosine of that particular angle is given by the base into hypotenuse, where base is delta x and hypotenuse is equal to delta s. Similarly, delta y become delta y by delta s, and delta z is equal to delta z by delta s itself. And nx dash, here we'll add nx dash will be delta x plus delta x plus delta ux, because initial the position was ux, then you change the position of delta change. Initially the p dash was delta p x plus delta x, and then it is changed to delta ui for q. Similarly, ny delta y plus delta uz by delta s dash. Right? Delta s dash is the new length of p dash q dash, which originally was pq itself, and delta z plus delta uz and by delta s dash. So here also you are doing the same uh, calculation for nx dash, ny dash, nz dash, and it is nz dash, which is nz dash, uh, which is showing us the reaction cosine of the line p dash q dash in this new equation along x-axis, y-axis, and z-axis. Here we are adding the, as it is the cosine of the angle made with the x-axis by the line p dash q dash, we are adding as the base of this rectangular element as x, which is original coordinates of q, plus the change in delta x, which is the original component coordinate of p itself here. What original component of p dash itself. Say that too will be divided by the hypotenuse delta A. Same is the logic for delta y plus delta u by delta A, delta z plus delta uz by delta s. Now substitute delta s dash for equation 27, that is equal to, that is given by then substitute for delta s from equation 27 for delta ux, delta ui, delta z from xyz. So what will happen to this equation will be to take this particular form. Delta s is equal to 27. Just 1 second, please. Delta s. Oh. The delta was 28. What is delta s dash was delta s dash is equal to delta is 1 plus epsilon 1 plus epsilon pq, which epsilon pq is the strain of delta s or rate of change of delta s along the rate of change of delta x per unit length, because delta ps us epq is equal to delta s dash by delta s itself. So you replace delta s by delta pq, and what will happen, ux, delta ux, delta ui, and delta uj. This is also given earlier. We have discussed 7.7 ABC, where delta ux is equal to delta ux by delta x by into delta x, delta dux by dy into delta y, dux by delta z into delta z. If we pick all these equations, then this equation will take the particular form. 4, take this particular form here. 1 plus 1 plus f sub pq, and where both side delta s dash is eliminated, and 1 plus dux by dx into f sub, and nx is delta ux by delta y and y delta ux by delta z to nz. So 1 plus f sub pq is d delta un by delta x into nx plus 1 plus delta ux by delta y into nq and delta ux by nz delta 0. So all this equation index means nz nx dash is the reaction cosine of the line p dash q dash, ny dash along x-axis, ny dash reaction cosine of the line p dash q dash at along y-axis, and same is the reaction cosine along z-axis. So if we know these reaction cosines and if we know the rate of change, so you can calculate the value of EPQ by using this equation 29 itself. Okay, more or less we are at the finish of our time. I'm ending this view here. Thanks for your presence.